Right. The IP version that we have learned for this long days is version 4. We all know about IP version 4. It's 32-bit binary. We have ARP, we have DHCP. We saw RIP version 1 always broadcast. So broadcast is supported and much more thing. Whatever is relevant to compare, I'm writing here. We learned a lot in IPv4. Now we are in IPv6, which is 128 binary bit size. So the address size is bigger compared to IPv4. No ARP. If no ARP, then how are we going to learn neighbor? Here, ARP is used to learn the neighbor MAC address. If no ARP, how are we going to learn neighbor? We use ICMP version 6 along with an address called link local. This is how we discover neighbor. We use ICMP version 6, and this ICMP version 6 is going to use a link local address. That's one type of IPv6 address. We'll talk about that in a few minutes. Link local address. Link local address always starts with FE80. FE80. So using this link local address, ICMP version 6 can discover neighbor. That's why there is no need for ARP. In IPv6, we don't have address resolution protocol. In IPv4, we have DHCP with DORA, discover, offer, request and acknowledgement, which is also called as stateful DHCP. You don't have stateful DHCP here. We have auto address configuration. And there is unicast, multicast, and anycast. No broadcast. In IPv6, no broadcast. You see, ARP uses broadcast, DHCP uses broadcast. That's why we don't use such things, because they all use broadcast. Broadcast means what? Sending to anyone. We do not know whom we are sending. We just send to everyone. Anyone can receive your packet. That's broadcast. Not secure. IPv6, no broadcast. Unicast, multicast, and anycast. And you see, we learned NAT in the previous class. If I ask you what is NAT, how will you define? Try, anyone. How will you define NAT? Okay, in another word, we can say it's the translation from private to public, correct? It's a translation of address from private to public. Okay, I'm convinced. Okay, fine. Now, IPv6 is too big, so there is no need for private public. As a result, there is no need for NAT. No NAT. No NAT. We don't have private public kind of schemes. In IPv4, because it is just 32-bit, with which you have to give internet to the whole world. With just 32-bit, you need to give internet to the whole world. That's why we have that NAT. That's why we have private and public. So you need to do NATing whenever you want to do communication with public. But in here we see you have plenty of address in IPv6. Plenty means more than enough. You have more than enough address, more than enough. It's not just enough, more than enough. Because you have more than enough, you only give public IP address to everyone. And all are going to be in public, so there is no need for translation. There is no private. Alright, so there is no NAT. Do you have any question on this, what I have covered so far? Okay. Now we have 128 bit size IPv6 address, 128 bit size. But you know, this 128 bit need to be written in a small form. 128 digit, who will write? 128 digit. If your phone number is 128 digit, how will you feel? The 10 number phone number, I don't really memorize, I don't by heart, I don't remember. I hate recollecting phone numbers. Just 10 digit. How will you handle 128? That to 0011110000010. Difficult. 128 bits in size is IPv6, but handling 128 bit is difficult. So what happened is, it is converted into hexadecimal. IPv6 is written in hexadecimal instead of binary. I remember I taught you one day that bit of hexa is equal to 4 bit of binary. 1 bit of hexa is equal to 4 bit of binary. Do you remember yeah, F means what? 15. To write F, that 15, you need this 4 bit. 8 plus 4 plus 2 plus 1 is what? 15. So 1 bit of hexa is 4 bit of binary, which means if I need to write in hexa, I need to divide by 4, which is 61, which is 32, which is 32 hexa bit. 32 hexa bits. So in binary it is 128. IPv6 in binary it is 128. In hexadecimal it is only 32 bit. And this 32 bit, for our convenience, it is written like this: 4 hexabit groups. So how many groups? 8 groups. Hexadate. 4 hexabit groups. Yeah, you see 8 groups of 4 bit. 8 multiplied by 4 is what? 32. So this 32 bit is written in groups of 4 bit. 8 groups separated by colon. Separated by colon, not dot. IPv4 address we used to separate by dot, isn't it? 192.168. That's how we write dot. Here it is not dot, it is colon. 32 bit is written in 8 hexadate, meaning hexadate means 16. You see, we just saw 1 hexabit is equal to 4 bit of binary. If I will write in binary this one, how many bit it is? 16 bit. 4 plus 4 plus 4 plus 4 is what? 16 bit hexadate. This is 1, 2, 3, 4, 5, 6, 7, 8. 8 hexadate. 8 fours are 32. If you want to say in decimal, sorry, if you want to say in binary, 8 16 binary bits each. 8 16s are 128. 8 16s are 128. Okay. Now, IPv6 is written in hexadecimal and it is grouped with 4 hexa bits of 8 groups separated by colon. Next. Because it is big in size, there is no need for subnetting like what you used to have in IPv4. In IPv4, we used to take some host bits for doing subnetting. Here we don't have such problems. We do have subnetting, but not a difficult subnetting like borrowing and doing, like what you have in IPv4. Here no borrowing, just using bits, that's all. Using the reserved available bits. You see, the first 64-bit is for network and the other 64-bit is for host. The network bits and the host bits, they are equally divided. 64 global prefix. We call it as global prefix. We don't call it as network ID or network bits. It is called as global prefix. And the other 64-bit is called as interface prefix. Spelling wrong. AL. Global prefix. Global prefix. PREFIX. And this 64-bit is called as interface prefix. I'm sorry, this pen is not writing well. Interface prefix. So that 128-bit is equally divided. The first half is 64-bit global prefix. The last half is 64-bit interface prefix. Global prefix is same like network portion in IPv4, network ID. Interface prefix is like a host ID. See, in IPv4 we have classes, class A, B and C. In IPv6 you don't have any classes. No classes. In IPv6, no classes. This is the only separation of reservation of bit. Class, there is no class A, class B, class C. 64-bit of global prefix, 64-bit of interface prefix. In this 64, according to the standard, this 16 bits will be used for subnetting. Sorry. The 16-bit will be used for subnetting. So, you have a network. In that network, if you put 1, that becomes new network. If you put 2, it becomes another network, another subnet of this network. And if you put 3, it is another subnet of this network. So subnetting is simply adding bits. Easy. Without subnetting, how much is the network portion? It is 48 bit. Plus 16 bit is subnetting. Totally you have 64. Alright. Now we have seen how the IP address is divided for network and the host. 64 bit of network portion, which is called as global prefix. Another 64 bit of interface prefix, which is equal to the host ID. Now the type of addresses. Before we go to the type of address, you see all the address will start with 2000. It can be 2000 or it can be 2001 to something starting with 2000, okay? All addresses are starting with 2000. Now, let's take one address. 2000 colon 0001 colon 0000 colon 0000 colon 5000 colon 0001 colon 0002, right, colon 0001. Let's say this is the IPv6 address. Are we going to type this big number? How many digits you have? 32 digits. Actually speaking, you no need to type this 32 digits. See, these leading zeros can be omitted, can be avoided. So I can write 2000 colon 1 instead of 001. I can put 1. Because that leading zero, is there any use? Is there any meaning? Leading zero? Leading zero has got no meaning. But this zero has got meaning. Hey, if you cut this zero, the value is 2, not 2000. But if you cut this zero, it is still the same 1. Whether you have 0 in the front or you don't have, it is 1 only. So, you should not cut this 0. You should not cut this 0. You can only cut the leading zeros. And then, instead of writing this 40, you can write 1, again 1, and then 5000. And then this continuous leading zeros not needed, not needed, not needed. Again, this can be shrinked like this. If you have continuous zeros like this, you can write 2000 colon 1 colon colon. That's just empty. Colon colon 5000 colon 1 colon 2 colon 1. You see, this is the best one. All three means the same. But this is the best and the easiest way of writing. Same meaning. So when you type this one to your laptop or computer or a router, it understands that there is 20 here. How? Because the 8 hectates should be there. 1, 2, 3, 4, 5 and 6 is there. So balance 2 hectates should come here. Hexadates. And that hexadates will be 0. That's why it is blank. Colon, colon. Did you understand? I'm going to give you an exercise. Let's see how you do it. 2025 colon 0000 colon 0000 colon 0000 colon 0001 colon 0000 colon 0000 colon 0002. You finish writing, then you tell me the answer. Have you done? No problem. I will do it. If you have done it is okay. You can verify now. 2025. You see, here also you have continuous 0, here also you have continuous 0. You can put colon only for any one of this, not for both. Any one of this. I would like to put colon for this one. Colon. This leading 0 I remove and then I just put 1. I said only once you can put colon, so how do we write this one? 0 colon 2. This is the right answer. Copy this, I'll give you another one. So consecutive zeros you can remove and put colon, but it cannot be done more than once. Only once. Is that clear? Okay. Then I'm going to give you a homework. Classwork. 2024 colon 0002 colon 0000 colon 0000 colon 0002 colon 0000 colon 0000 colon 0004. Write the answer afterwards. You let me know. So the multicast address are same like IPv4, the ending number, but this one is FF02 instead of 224. FF02 colon A is EIGRP, A is 10. FF025 is OSPF. FF02 colon 9 is RIP, next generation. Alright? Okay. Now, there is another one called Anycast address. Which is defined as 1 to the closest. 1 to the closest. We'll see these things in detail when we come to IPv4 CCNP. Now, there is another thing. What is that? There is no support for no broadcast. No broadcast. So we have Anycast, we have multicast, we have unicast. In unicast, we have two flavors: link local address and global unicast address. Link local address will always start with FE80. Global unicast will start with 2000. Did you understand? Don't worry about any cast now. So unicast and multicast you should know. In unicast you should know that there is link local address and global unicast address. Okay, now let's quickly revise from the beginning. The IPv6 is 128 bit size, but it is not written in binary. It is written in what? Hexadecimal. How many hexadecimal bits is IPv6? 32. And it is separated in 4 bits in a group of 8 groups, correct? Of 8 groups. Okay. So next is IPv6. There is no ARP. Why? Why there is no ARP in IPv6? ICMP version 6 uses link local address to discover neighbor, so there is no need for ARP. There is no need for NAT. Why? Because you don't have private public address. Here we got more than enough, sufficient amount of IPv6 address to be given to the whole world. So there is no need for private and public scheme, so there is no need for NATing. And there is no DHCP, stateful DHCP, because multicast is not supported. So you don't use any multicast, sorry. Broadcast is not supported. So we don't use any feature that uses broadcast. If you remember, DHCP and ARP uses layer 2 broadcast. IPv6 don't use any feature that uses broadcast. Then what do we do in IPv6? We use auto address configuration, which is using multicast address, not the broadcast. And then we learned how to write an IPv6 address. We don't use leading zeros. We don't use consecutive zeros. For consecutive zeros, we just put colon. If there are 2 sets of consecutive zeros, then one of it we put colon, the other one we put colon, 0, colon. And then type of addresses, we saw unicast address and multicast address. Unicast address, you know, it is 1-to-1, and there are 2 type of unicast address. One is link local address. As we already learned, it is for neighbor discovery, used by ICMP version 6, and link local address will always start with FE80. If you see an address starting with FE80, you should know that this is not the address for communication. This is the address for discovery of neighbor. Global unicast address always starts with 2000. Multicast address will always start with FF 0 to colon. If it is EIGRP, then it is A. If it is OSPF, it is 5. If it is RIP NG, it is 9. FF 0 to colon 9. There is also Anycast, which is nothing but 1 to the closest, and no broadcast support. We also learned that subnetting is very easy because the 4th hexadate is reserved for subnetting. So just by adding increasing bits there, you will get new subnets. For example, you see this is one network. If I put 1 here, that becomes another network. If you put 2 here, then it becomes 3rd network. If you put 4 here, it becomes another network, So you have 16-bit. In 16-bit, you can produce 65,000 subnets of each network. So subnetting is easy. Any questions so far? Okay, then we'll